Another way you can differentiate a compound from a mixture of the elements that make up the compound is in the composition of the compound itself, of the substance. Okay, unlike a mixture of the elements, a compound has a definite composition. Exactly what do we mean by that? Let's look at an example. If you had a mixture of hydrogen and oxygen, okay, let's say you have a mixture of those two elements, well, the amounts of hydrogen and oxygen relative to each other, the relative amounts, will vary depending on how you prepare the mixture. Whereas pure water, okay, it is a compound that's made up of hydrogen and oxygen. Okay, if you were to break it down into hydrogen and oxygen, it will always yield 11.21% hydrogen and 88.79% oxygen by mass. Okay? And if you're going to make it from hydrogen and oxygen, you're always going to need that ratio of hydrogen to oxygen to make water. So it's a definite composition. Hydrogen peroxide. This is another compound that's made up of hydrogen and oxygen. If you break it down, it will always give you 5.94%. If you have 100 grams of it, it will always give you 5.94 grams of hydrogen and 94.06 grams of oxygen for every 100 grams. Very well defined. Okay? If it's pure compound, it always gives the same proportion of the elements that make it up. Whereas if you just have a mixture, it depends on who made the mixture, you can get different percentages of the elements that make it up. Okay, so let's see if you understood that with this question right here. The percentage of chlorine by mass in a 10-gram sample of a compound is 25%. What is the percentage of chlorine by mass in a 20-gram sample of this compound? Exactly, it's still 25%. Very good. A 16-gram sample of a compound contains 12 grams carbon and 4 grams hydrogen. What is the mass of a sample of this compound, if that sample contains 24 grams of carbon? What's the mass of hydrogen in this sample? I'm going to pause. Okay. So you said that it's going to be 8 grams hydrogen and 32 grams overall. Why? Proportions. Okay, so 12 grams carbon is to 4 grams hydrogen. Here's a way you can do it. 12 grams carbon is to 4 grams hydrogen, right? As 24 grams carbon is to X grams of hydrogen. That's one way you can do it. So you can say 12 over 4. That means the carbon to hydrogen ratio is what? 12 over 4, that's always 3 times. The mass of the carbon is always going to be 3 times that of the hydrogen. So 24 is going to be 3 times 8, right? So you can do it this way. You can say 12 over 4 equals 24 over x. Cross multiply. 12x equals, oh, it's easier not to cross multiply in this case. But if you're used to doing it, you can just say 12x equals 24 times 4. Divide both sides by 12. X equals 8. Okay. Now, another way you can do this is using what's called dimensional analysis. You can say x grams of H, okay, is equal to 24 grams carbon times, okay, 4 grams hydrogen for 12 grams of carbon. Grams carbon cancels out. So this one keeps track of the unit. This approach doing this problem keeps track of the units. So x times 4 over 12 would be 8 grams of hydrogen.